The main focus of the lab is really looking for new treatments for multi-drug resistant diseases. So that can include bacteria, we're going after fungi that are multi-drug resistant, or even possibly going after cancers that have developed resistance to certain drugs. We tend to look for new peptides that target these pathogens and diseases rather than small molecules, which is the traditional drug modality. And that's just because we believe that peptides have a bit more diversity in their size and their structure, which can allow them to inhibit processes that maybe small molecules can't go after. Yeah, we use a mixture of quite a few different techniques. I think fundamentally we are kind of a microbiology bacteriology lab, and we use synthetic biology, which really harnesses DNA manipulation and cloning to engineer bacteria using plasmids to both produce and then screen whether or not a peptide that we're interested in can inhibit the growth of a bacteria. And then we kind of take that system that we've developed, which we call surface localized antimicrobial display, and we're trying to move it into new organisms. So we know we can do that in bacteria, but we would like to also apply that technique in fungus or in cancer cells to see whether or not we can have the fungi or the cancer cell produce the product that we think might inhibit its own growth, and then literally look and see whether that growth is being inhibited in real time. This allows us to go after hundreds of thousands of targets rather than synthesizing each one individually and testing it, which would take a very, very long time. We can do hundreds of thousands in just a single assay rather than 10 or 20 in a week or something like that. And then on top of that, we do a lot of biochemical analysis of the peptide candidates that we have to look at their size, their structure, how are they inhibiting the growth of the certain organism that we're trying to target. And then we want to assess whether or not it's healthy to use as a therapeutic. So we need to know whether that drug is toxic to human cells and whether it works in vivo or in an organism. And to do that, we generally use the Galleria melanella model of infection, where it's basically a wax worm larvae, a little maggot. You can inject it with a pathogen and then inject it with a potential treatment, and over a day or two see whether or not that treatment is effective in preventing the worm from dying. Yeah, students in the lab, I kind of look for people who are motivated to do science. So people who are just generally interested, curious, and want to be doing research in the lab. So that kind of self-motivation is really important, and then having critical thinking ability is also absolutely necessary when you're trying to do a PhD. So you can't always be told what to do all of the time. Many times you have to be able to at least take the step out there on your own and try to figure out the problem at first on your own, and then of course reaching out for help when you need it. So as far as a student goes, technically I don't need them to have any kind of specific background in one thing or the other, whether that be bacteria or tissue culture or something like that. It's really just that ability to be inquisitive and self-motivated that's most important for me when I'm looking for a student. Then mentorship-wise, because I'm looking for that motivated student, I'm not the mentor that's going to be telling you exactly what you should be doing and watching you every moment at the bench to ensure that you're following the plan that I've kind of laid out for you perfectly. I'm more hands-off. I like to point you in the right direction, give you the background information that you need to have to do the research that you're interested in, and then really be there more to help you along the way rather than to be shoving you down the road.
So Justin really understands that, first and foremost, I think that people in the lab should be happy, and they should be content with what they're working on. They should be interested in what they're working with, and it's part of the reason that I agree so much with his work philosophy that I decided to actually follow him all the way from Austin, Texas, here to Kansas City. So I really enjoy the kind of effort he really puts into mentorship and making sure that we have guidance both in the lab and also outside the lab, and making sure that our lives are going the direction we want them to. The big standout thing for UMKC is that everyone in the department is very collegial, very friendly, very easy to talk to. Everyone is just really excited to be here and be doing their own research, which they think is cool, which is a very welcome change of pace, especially from other departments where people feel a little bit more insular. They're plenty nice to talk to, but we don't talk very often. But everyone in the department here seems to communicate pretty well. When I first learned I was moving to Kansas City, I was in the middle of a flu or a cold or something, and the first thing I did was like, well, does Kansas City have Asian grocery stores? And I was actually pleasantly surprised at the number of options. And so it is still relatively diverse living here. I find everything that I need and I'm looking for. living in Texas my whole life, it's really nice to actually have 4 seasons for once. The city's actually really pretty during the fall, and I think during the winter when it snows, and so that was a very welcome change of pace.